Okay, hello everyone, and today we're going to present and talk about the audio-video quality monitoring with AI. Here we have Alvaro Laserna Lopez, who's the Director of Head and Research of Development for the TestDevLab audio-video quality. I'm Adrian Sminins, who's Technical Project Manager at TestDevLab, and we have Varun.
Hi, I'm Varun Singh. Been working with the video for the last 20 years, and I'm the Chief Product and Technology Officer at Daily.
So, yeah, you want to introduce yourself as well?
I mean, the introduction was good enough. So, yeah, Adrian, please go ahead.
Okay, if anyone has any questions during the discussions or some of the slides, feel free to ask, and we'll try to answer that as well. So let's start with the monitoring strategies for streaming solutions. So, Alvaro, what are the main strategies?
Yeah, so for the past 5 years at TestDevLab, we've been trying to improve the quality of reports that we generate because we have a bunch of clients that work in the media content delivery industry. Those are both for streaming services and also video call conference applications. And at first, it was very interesting work because it was manual work, people just looking into streams, doing some network simulation and catching whether the quality of the audio video was correctly, and if there were no drops, audio video syncs, unsync. And so that manual work kind of dragged the development of these platforms. And then we started to develop our own metrics and also kind of implementing existing metrics into our pipelines to be able to automate these workflows and give more meaningful and objective results to the clients. Otherwise, if we are all the time doing subjective evaluation, the overtime graphs that we obtain out of these metrics, they are not reliable enough. We can have maybe a 3-year score in 2012, but then we get also a 3-year score in 2019. You might think that the quality is exactly the same from 2012 to 2018, and that's not the truth. It's just like the quality overall of all the applications has improved over time. So that's why reliable, objective metrics are so important. And Varun?
Yeah, so with subjective, the problem is that you need a cohort of 100 or so users which are kind of consistent over time to get it right. If you don't have that, then you have to do objective qualities. But the objective qualities for streaming versus real time is quite different, because in the case of streaming, you have some kind of delay or latency or buffering. And the main metric that most people are looking for are like rebuffering events and duration. So typically you want to see no rebuffering events and no rebuffering durations. And then the question becomes like, how often can you have them? The rebuffering as little as often, and the duration should be very short, right? So those are the two things that you're competing. Whereas in real time, you can actually modulate the quality of the encoder itself directly. So you have, the main question there becomes like, how quickly do you react to bad network? And what is the quality you drop to? And if you don't drop to, like, what happens? And typically freezes are common or uncommon in real time, but they're really very short, typically a second or two. But if you're doing a video call, the expectation is completely different than if you're watching like Netflix or something like that.
Yeah, I will even say that the like measure bar for the best quality on video calls is so much lower than on the streaming services. And when we have these algorithms that measure picture quality, we need to change. We need to use a different model for streaming service and a different model for audio video calls. Mostly because, the content delivery on video calls is maybe 720p and high compression rates to encourage that the UDP protocol kind of like delivers consistent and like with lower latency. And in TestDevLab, we are now trying to create models that we can add context to it. So to not only give the algorithm the image from the receiver end, but also give context about what is being displayed. Like, this is a video call. Is this a video game? Is this animation? Is this a film with real people or just landscape? So kind of giving the model more information, giving the algorithm more information will give a much better understanding of what is the actual score. And because if you use the same model for a film, that is, let's say, like, there are people there, and you can perfectly see them crisp. But then you use the same model for Minecraft, video game. You will see that they are really pixelated, and the same model will give you a lower score just because it's pixelated, and that's kind of considered as low quality, but actually it's not. So giving context to the algorithms is really important. We have that information because we have read the title. We have like much more information than just the image.
But I think it also depends on, like, if you have the reference video or not. So if you're like comparing with a reference, which is in the case of Minecraft, like, you could see the compression, like local compression versus received compression, and then decode both of them, and you can do a delta between that. So, like, okay, the scores will be low because they're pixels, but the delta between the two scores, between the local and the remote, might actually be very small, which is what you want to communicate to the people. Like, it's not that so there are different ways to do this, for sure.
I think also the main question would be, how do you do it in terms of the hardware, right? Or here's the audio video quality measurement setup. I think that Alvaro can give us a bit more insight and talk about it. It's really on a high level note. So yeah, go ahead.
Yes. Well, this is one of the setups that we have at TestDevLab. We tend to do an end-to-end testing where we have actual, like, well, a sender or a streamer, then a receiver or the person that actually consumes the stream. And then we have a network simulation router where we can provide with low bandwidth, high packet loss, different kind of jitter that will definitely influence the performance of the application.
It's basically, we have gathered a lot of information from different airports and cafes to simulate real life network conditions, how it happens. For example, if it's burst packet loss at the cafe when there's a lot of congestion there, we can put that on the router, and we can see how in real time it will change the data and how the application will perform on this particular setup.
But one of the things that Varun mentioned is about if we have the reference, and that's a very key point when we are measuring quality, and it's because when we are trying to monitor different applications, sometimes we don't have that reference. And yeah,
live streaming would be a good example where there is no reference. Like, that's different from the streaming Netflix example where, like, you can really optimize ahead of time depending on the title of the movie, for example.
Yes. So in those examples, I think is really important if we can provide both context, and at the same time, it would be really nice to add even the audio part to give even more context of what is happening, because if we have the audio as well to measure the video quality, this will give the information to the model to be able to actually provide with consistent scores when we don't have an actual reference, when we don't have the video reference. And so this is somewhere that we are trying to move forward to get more reliable metrics on live streaming and live monitoring for different platforms.
Okay, let's go to the next slide, and let's explore available AI tools industry and how it's possible to test the AI solutions. So, Alvaro, how it is possible to test the AI solutions?
Yeah, well, to test AI solutions, first of all, like, we are hearing AI everywhere nowadays. It's not like it just happened the last 2 years. AI was here much before that. It's just like the introduction of ChatGPT and DALI and other generative AI kind of algorithms have blown up, and it's like now in everyone's mouth. But before that, there were plenty of AI algorithms running around, both in for example, background replacement on video calls and other on streaming, and that right now runs through AI algorithms. It's not like mathematical, just simple mathematical equation that removes the background magically. So that's one of the things. Noise removal on the audio side is also run by AI tools, and they are getting better and better. Transcriptions, like the one that we see there, it's also run by different AI algorithms. But maybe, Varun, you have more in mind?
Yeah, I think the thing that's changed in the last 2 years since ChatGPT was that, like, all these things are one way. If you think of it, it's like converting speech to text. In the case of background removal or replacement, it's one way in the sense that you do segmentation and you say, like, find me background, and then you do something on that background, but it's only one way. What the generative AI has shown is that you now have a path of using LLMs, large language models, to actually interact with it. So in the past, like, if you created a bot like Alexa, it's very interrogative. Like, you would say, like, what is the weather? Set a timer. Like, I think the most use case for Alexa is to just set timers. Ask what is the weather and what is the news. So it's just information retrieval. But so what's changed in the last year is that people are building things that Google showed us like maybe 5-6 years ago with their first demo of like calling a restaurant and booking something, and the bot spoke to you, and the bot mimicked human behavior in the sense that it did ums and ahs, which you expect from people, and it paused, just like I'm doing right now. Like, I'm thinking and talking at the same time, so it's not the same thing as a bot which has all the information and just speaks it out perfectly. And I think today, all of us, if you have a little bit of information and coding and access to databases, you can actually build those kind of bots very quickly. So that's where I think this whole generative AI is going. You'll see, I think in the next 6 to 12 months, hundreds of startups trying to solve this problem for banks, for restaurants, for various use cases. And I think the main thing there that we're all worried about is hallucination. Like, what are the things that the bot can say? What is it trained on? So, like, what recently Air Canada got a fine, or did not, like, their chatbot did not told a customer that the flight would be comped because or will be discounted because his father passed away and he was booking it under these duress circumstances, and the bot said, yeah, we'll give you a discount. Then the bot did that, but the booking system did not. So the person flew, came back, said, I dispute this charge, and they went to court. Like, Air Canada took them to court, and the judge said, actually, the bot did say this, and Air Canada tried to show that the bot is not an employee. It's not a person. Of course, like, now the legal decision there was that it is. And what happened immediately is Air Canada removed the bot, right? Instead of solving the problem. But like, that's like the theoretical problem manifesting in real life, which now we have to think about, because those are the situations that, like, if you call up a restaurant and the restaurant says, yeah, you have a booking for 4 people, but for some reason it hallucinated that, then that would be a problem, right? Like, you would show up, there is no table, and now it's overbooked, right? So those are the things that I think we will have to think about. And there are things like, did the bot hear correctly? In the case of like AI transcriptions and such, like you said 3, it heard 5. Should have, like, if there's any dispute in the transcription of what it understood, how does it know? Does it give it a high confidence score? Like, how does it like really know you said 5 and not 3 and such? So those are interesting things that we need to start thinking about.
Let's move forward to evaluation part of the AI solutions. For example, how to test the performance and how to get the benchmarking insights. Alvaro?
Yes. So actually, I want to put an example that we've done very recently at TestDevLab, and is that, again, LLMs, ChatGPT has given us a lot of power to increase our testing capabilities. And one of the examples is for transcriptions. We've recently done a study about which tools, which conferencing calls and streaming services does better transcriptions for different these calls or these streams. And what we did is that the first thing that came to your mind, if we have a fixed script, a fixed video with people talking, is that okay, how do you get it in the receiver end? And then you compare the baseline, the text that you knew it was spoken, with what you receive on the receiver end. And then you see what is the word error rate. The problem with word error rate is that one single word in a 6-hour, in a 3-hour conversation might change a lot of the meaning of the whole conversation. And so if you have 1,000 words and only one of them is wrong, but it has changed the semantical or the meaning of the whole conversation, then everything goes downhill. The transcription is not good. And then the word error rate will give you that is actually very low. And you will say like, okay, this application is actually performing really well. But there are those little details that matter a lot. So what we did is we actually use ChatGPT to check for the semantical correctness between the baseline and the actual received transcript. And these gave us a much better understanding of how good were the transcriptions. And instead of using the word error rate, which is okay, this gave us a much accurate information.
I think it's a really good idea because you're playing to the strength of the LLM to actually give it something as input and say like, is this positive? Is this negative? Did it what's the like speech recognition of this? So yeah, I think it's a really good example of using an LLM for its strength.
Yeah. So eventually is testing AIs with other AIs. That's one of the ways of testing AIs. If you have a specialized AI that works really well at something, and then you have another AI that works on a different domain, but maybe there is like some confluence between those two, then you can use them to test one to each other. And that's just like trying to think a little bit out of the box and see like with the tools that you have, how can you benchmark other AI tools.
It gives me an example of something that we didn't build. We kind of, I was talking about like these things, these bots that you talk to and that can do recording of like going to a restaurant and converse with you. But the first thing that we built just to do that was just like a 4-year-old sometimes talks back to you by just repeating what you said. So you say hi, it says like stop doing it. It says like stop doing it. And you say like go to your room. It says like go to your room. Like very annoying 4-year-old, 5-year-old. They do it as a game, but we built a bot which inadvertently did this, which was you talk to it and it just repeated back. And that's actually a really good way of like testing. So if you say a piece of text, it does speech to text or text to speech and then does speech to text. I got it mixed up, but you understand what I mean. Like, so it'll speak back what you said in its own voice, right? Mm. So that would give you a good example of like it's repeating what you just said and if it got it right.
Mm. Yeah.
Okay, let's. How about the Daily's progress in processing the raw video and audio side?
Yeah, so we've been, so Daily, for those who don't know, is a WebRTC video and audio provider. We basically ingest WebRTC streams. Mainly you can build things like video calls, but folks can actually connect outwards to using SRT, RTMP, HLS, and live stream a conversation. So like this thing could be happening online with the three of us in our browsers or on desktop applications, like talking to each other. And then just like Twitch, you could have like large scale distribution using any of the streaming protocols that connect. So one of the things that we quite often want to test is like the video quality of the call that's happening between, let's say, the 3 or 5 or 10 of us. And then we are piping to different streaming technologies. So we just want to make sure that the SRT out, the RTMP out, the HLS out is all working correctly. So in the end, we have like this large scale testing framework for all testing across all of this. And in the past year, I think we've used TestDevLabs quite extensively to like test some of these factors just to make sure that like what we are seeing in our benchmarks is third party validated. And also like sometimes we see different results and we're not sure if it's like our testing methodology versus, like someone else's testing methodology. So that's how we use TestDevLabs. In case of raw video and audio, I think a lot of the things that we're looking at in 2024 today is around AI and things like on the video side, it's like object detection, like people want to detect objects in real time, remove objects like for content moderation purposes for both audio and video. In the case of audio, they want to do live translation. So I'm speaking English right now. Can you do real time within 800 milliseconds, let's say a Spanish track, and also move my mouth in accordance to as if I was speaking Spanish? And that's actually something that we've got, like the video is down to 1 second. So with less than 1 second delay, we can actually stream that. I think we're trying to get it to less than 800 milliseconds, which would be in line with the audio that we are translating in real time. We've also been able to clone, like for example, last week we ran a hackathon. I cloned my voice with a 1 minute track. So it's not perfect, but it does quite well. Like when I couldn't fool my mom enough, but enough to like for her to say like, yeah, it sounds like you, but not quite, because the American accent still comes through, which is the base model. So things that it's not able to create, it uses the American voice, and that like creates some tension between like how I would uniquely pronounce it versus like what the model creates. But that's really a good sign.
Have you seen like any during those live transcriptions or like text to speech, any like funny things going on? Because I remember when I was starting to play with it, at least with some of the available like publicly available frameworks, there were some words or letters that it just started to do like some weird sounds.
I think there are some things like in the speech to text, which is where most of the issues happen, because we work in a very diverse work environment. Sometimes the names are not anglicized. So those are definitely an issue. Those problems can be solved these days. So if you know this person is going to show up in a meeting, let's say if you have all the attendees list that will speak, you can actually phonetically, there's a very simple LLM command which will phonetically, and then you can just insert it, right? Like at the beginning of the call, you tell the transcription engine, like here are the word, like the sounds. We don't know how the sound will come, but here's the phonetic and this is how you do it, right? So those are one. The other place where it struggles on the text to speech side typically is acronyms, because like especially if you work in this industry, there are like hundreds of acronyms, and the LLMs don't quite actually know some of them, so they will mispronounce them for sure.
So some of them, they are even like the same for different things, and so it's really, really confusing. I hate the acronyms. It just makes my brain explode time to time. But well, there is what do you think about? Do you develop your own LLMs or do you use third-party ones or any other algorithms?
I think it's a really interesting time. We don't generate our own LLMs. I think there are basically two categories right now. You just use Gemini or ChatGPT or Claude, whatever you have access and whatever price point. Like price is like the main determination there. Then there are things like llamas and like I think Microsoft just announced something 2 days ago, and is a very light LLM. So typically where you want to use your own LLM typically is for something called retrieval augmented generation, or RAG. That's where you put in like your technical terms, your like basically anything that's related to you. You don't want like ChatGPT or Llama or whatever to be trained on that. You don't want to basically want to play to the strength of ChatGPT, because you can have a conversation with it. It has some information. Things like even our technologies, it understands very well because it read all the specs, right? Like the things that it's trained on is like publicly available documents, which are high quality. So it has all the, books, the literature books. It has all the specs. So if you say like, what is SRT? It will tell you what is SRT. But your flavor of your technology, if you've done something, that's your unique thing, and you don't want to train the global LLM on that. So typically you do something called a RAG. You put your own database up, vector database, you put your stuff in that, and you insert it into the prompt. And I think Gemini just announced last week, was it, like they have a 1 million token input compared to like, 20,000. So that's how far it can read behind. So like if you have a conversation with, 20,000 lines, let's say, at that point, like ChatGPT will forget what you initially told it. So you have to reiterate with a lot of the LLMs. Like as the conversation goes on, you have to like remember that the LLM will forget if it's a long conversation. So you have to bring back things that you already told it. With a 1 million context size, you don't have to worry, because like 1 million tokens is quite a lot. And token is not a word here. Token is usually a sentence and can be a paragraph. So, 1 million gives you a lot of context.
It kind of feels like the growth of tokens, of memory that it can hold, is growing at the same pace that like the computing power has been growing like year after year. So I kind of feel like in a couple of years or more, like the content, like the amount of context that can gather these LLMs is going to be.
It's true. I mean, like a year ago, last summer, the way you build some of these things and the way you build it today are completely different. The technologies are moving really quickly. So you can't really, like, you have to buy a lot more technologies in some sense. Like there is RAG, and we don't know if RAG or retrieval augmented generation will stay, because if the context windows become really big, you don't need RAG in that sense. So some of these things will change, and we have to keep abreast with some of how you build some of these things. But to me, it feels like 2000 or 2004, like when Web 2.0 or just before Web 2.0, there were so many competing ways where you could build a simple website. It's similar to that, like, and a lot of people were, building things, and you were learning from each other. So I think it feels a lot like 20 years ago.
Okay, we have a couple more minutes, and I would just want to ask if someone has any questions that maybe would like to answer. No one has any questions?
No? Oh, okay.
Okay. Then I think we can thank you everyone for coming in and listening to us. And thank you, Alvaro, and thank you, Varun.
Thank you.
Yep. Have a nice one.